But then suddenly I get this telegram from Penrose saying, offering you a postdoc position at the Mathematical Institute. Do you accept? No, these other offers of postdoc position I had got, they were very detailed, right? I mean, they said, how many years, what the salary was, what my duties were, etc. Here, there are two-line telegram, right? And I didn't know. And so it was quite expensive in those days, but I decided to call Roy because I wanted to know how much was his salary, because I did not have any independent means to live on, right? So I remember this call, which is a somewhat unusual call. Roger took my call and said, "I said, thank you for the offer, etc. But do you know what the salary is?" And of course, Roger had no idea what the salary was because he is not a very administrative-minded person at all. So he had no idea about what the thing was. So I asked him, "So is it enough to live on? Because I don't have any other income." He said, "Yeah, you can live on it." I said, "Okay, then I accept." Then she looks at my work permit and this was, so where are you going? I said, "Well, I'm going to Oxford." He says, "Which restaurant will you be working in?" So I said, "No, I'm not working in a restaurant. I'm working in Mathematical Institute." No, but what is the name of the restaurant? So I got really upset about it. And I said, "Well, I'm not working in a restaurant. I'm, you know, I'm going as a postdoctoral scholar at the Mathematical Institute in Oxford." Then she opened the work permit, looked inside, and said, "Okay," and then she stamped the thing. Right? I mean, this kind of a very, very strong racial attitude that people, of course, are going just to be a waiter in a restaurant or a bus conductor. Very often in those days, I would just wear whatever clothes I had. Didn't have too many clothes, so whatever clothes I had. So I had kind of an Indian shirt and pants, and then I gave talks and such thing. And then afterwards, Chris told me that he sensed there was some racism there, not among the people that I knew very well, but others, and senior people actually, that he sensed that there was some racism. They were making negative comments, but they were not really justified. Chris Isham was very positive to me. I was happy because he was a senior person. He confided in me. And so there were things like that at that time definitely around, even with some prejudices, even within academia somehow. Back to Oxford, what was kind of most interesting in those days was just the thrill of being with Roger Penrose. I saw Roger kind of groping in the dark to find some shapes which you don't know where they are or something, and before they actually come to light, right? I mean, he could sense that there is something here, right? And then after a while, they emerge in pristine beauty. And this thing, I think, is something that is very deep.
Good morning, sir. How are you?
I'm fine, thank you.
Hope you're doing well, sir.
Yeah, I'm doing fine.
Sir, just to recap, so far we have covered your early years, your time at Rajaram College and the Institute of Science in Mumbai, and then your journey to the US, including your graduate studies at UT Austin and the University of Chicago. We also talked about your interaction with Professor Bob Garrock and Chandra and your experience during discovery of Hawking radiation. Today, I would like to continue with your postdoc journey, your interaction with Roger Penrose and Stephen Hawking, and your transition into permanent positions at Syracuse and Penn State and other aspects. Since general relativity wasn't as prominent at the time compared to the fields like particle physics and condensed matter, how did you navigate that academic landscape when choosing postdoc positions and research opportunities?
Yeah. Now, what happens typically is that your postdoc positions are typically in the same area as your PhD. It's not easy for somebody who has done a lot of work in gravity to switch to particle physics, or vice versa, unless there is some specific reason, like some people, particle physics people, for example, currently they very much want to go into gravitational radiation. So then they might actually hire postdocs in gravitational waves and things like that. So normally this does not happen. So the statement is that my choice was really about since my PhD or my research work was more in gravity, the choice was naturally to look for postdoc positions in gravity. So, there are not that many gravity groups in the world. There are probably a dozen, more than that, and maybe even less actually, which are large enough to actually have postdoc positions and such thing at that time. And in the United States, for example, it was a small field. It has grown enormously in the last 10 years. But since at that time it was a small field, and so when I finished, there was really only faculty position open in all of United States in gravity for every 2 years, not every year even, just one faculty position every 2 years. So at one stage, just around that time, it was the National Academy of Science was actually building a statue of Einstein's, and they were seeking donations. And so they had asked Chandra for donation, and Chandra wrote a letter, he told me, saying that, well, it would be, instead of, in place of a statue, or in addition to a statue, it would be much better to try to create jobs for young people in this area rather than general relativity, rather than celebrating in this way. But nonetheless, he did send them quite a large amount of money as a check for this statue, which is in front of the National Academy. And that also is if it was my homeroom web page, the background is Einstein statue from the National. Okay, so I applied to these various places which are leading relativity centers at that time. So places actually in those days even invited you to come and give a talk or something like that, even for a postdoc position. Nowadays it doesn't happen. Postdoc position people might themselves go and give talks, but so I was asked to give a talk, for example, back in the University of Texas at Austin. The group there had changed because, unfortunately, Professor Alfred Shield, the director, had actually passed away, and that then hired more senior people and such things. But it was a very active research center for gravity. By gravity, I mean general relativity and associated physics, including quantum gravity. And so they asked me to come and visit. And actually, I was delighted because at that time, there was also Chris Isham visiting them. Chris Isham was a leading quantum gravity theorist from Imperial College in London, and he was working with Bryce Devitt, who was a senior, newly hired, or at that time newly hired, a senior person. Mm-hmm. And so I was delighted to go and talk there, etc. But then I had a very, very nice time. I had very good interaction. But I very often in those days I would just wear whatever clothes I had. Didn't have too many clothes, so whatever clothes I had. So I had kind of an Indian shirt, which long flowing thing, and pants. That shirt was the kameez, long. And then I gave talks and such thing, and then afterwards, Chris told me that he sensed there was some racism there, not among the people that I knew very well, but others, and senior people actually, that he sensed that there was some racism. They were making negative comments, but they were not really justified. Chris Isham was very positive to me. I was happy because he was a senior person. He confided in me and such. So there were things like that at that time around, even with some prejudices, even within academia somehow. So not too many, but this was one incident, and the only one actually that I was made aware of, that there might have been. Okay. But nonetheless, because perhaps I had spent 2 years as a student there, so a lot of faculty knew me and so on and so forth. So they nonetheless, informally offered me a postdoc position. And there were other places which are very, very nice places which offered me a postdoc position. So I had something like 4 or 5 offers, which was quite large in those days. It was because there's so few centers for general relativity. But then at that time again, Chandra intervened. And Chandra told me that, no, there's no point in going to any of these places. There's only one place you should go to, and that is Oxford, to work with Penrose. So I had sent a letter to application, so to say, and wanted to mail all those things, right? There was no internet, and there was transatlantic and all that takes a while. And I had not received anything back from Penrose. And then some deadlines were coming, and to accept, right? Because these places cannot keep the position open forever, because if you turn down, then they have to give it to somebody else and make the offer to somebody else and so on. So I didn't know what to do. So Chandra said, no, you should just go to Oxford. That's the place you should go to. I mean, it was so incredibly kind of him. But then suddenly I get this telegram from Penrose saying, offering you a postdoc position at the Mathematical Institute. Do you accept? Now, these other offers of postdoc position I got, they were very detailed, right? I mean, they said, how many years, what the salary was, what my duties were, etc. Here, there are two-line telegram, right? And I didn't know. And so it was quite expensive in those days, but I decided to call Rob because I wanted to know how much was his salary because I did not have any independent means to live on, right? So I remember this call, which is a somewhat unusual call, which Roger took my call and said, thank you for the offer, etc. But do you know what the salary is? And of course, Roger had no idea what the salary was because he is not a very administrative minded person at all. So he had no idea about the thing was. So I asked him, so is it enough to live on? Because I don't have any other income. He said, yeah, you can live on it. I said, okay, then I accept. That was quite a somewhat strange thing. And then on the basis of this, that of course I have to send letters thanking everybody else to decline the offer. And so it was their offer and such thing. And then I had to do my final oral exam in Chicago, which I did. My thesis was not one of the published papers, so it was not things that I had already published or something else. It was quite an ambitious idea about trying to reformulate or new way of doing kind of quantum field theory. Quantum field theory is quantum mechanics of fields, and fields are, so to say, infinite degrees of freedom, as they say. That is to say, there is a field at each point in space and time. And so, as opposed to something like a particle, right? Typically people consider a harmonic oscillator or the moon or the earth represented as a particle, just one particle, and that particle goes around. Moon, for example, goes around earth and so on and so forth. Here, the field is everywhere. So it's not the moon is just someplace, but here. And so there are really mathematically very deep issues associated with quantum fields. And I was proposing some new way of trying to do it. And so I, did my final oral exam and everything went fine. And Chicago in those days had no requirement of actually writing a thesis. The thesis you write is supposed to be submitted to a journal, and that paper which is published in journal is considered as thesis. There was no separate thesis. It was just the journal article. At that time, I did have 2 or 3 journal articles, but I did not have any. But this was not one of them. So, and it also had to be single authored. So the previous one was authored with Bob Garosh, and second one was authored with somebody else, and so this had to be single author. Okay, so I finished that, and then I wanted to go to. Then I was looking forward to going to Oxford. I was very excited, and then for personal reasons, I decided to go to Oxford through France, and so it was a ferry that I had to take to from. I think it was from Calais to Dover, probably. And in those days, you passed immigration or customs in the ferry if you were going by ferry and not flying. And so there was an immigration desk there, and I had got my work permit from Mathematical Institute, and I had to collect it in the British consulate in Paris, which I did. I must say that in those days I was not very careful about how I told you about flowing Indian shirts and such thing. And the picture that I had on the work permit was not exactly a very formal one. It was just wearing a shirt and something. And so I go, and then there was a British lady who was the immigration officer. And so I gave her, there are lines, so we stand in line, they go through and stamp your passport. So I had the Indian passport and I had this work permit. And so she looks at my work permit and just and says, so where are you going? I said, well, I'm going to Oxford. She says, which restaurant will you be working in? So I said, no, I'm not working in a restaurant. I'm working in Mathematical Institute. No, but what is the name of the restaurant? So I got really upset about it. And I said, well, I'm not working in a restaurant. I'm going as a postdoctoral scholar at the Mathematical Institute in Oxford. Then she opened the work permit, looked inside, and said, so, okay, and then she stamped the thing, right? But it was this kind of a very, very strong racial attitude that people, of course, are going just to be a waiter in a restaurant or a bus conductor. That was another very common thing for Indians. Most of the bus conductors were Indians. Some bus drivers too, and of course there was also a lot of Indian doctors in the National Health Service. But the general British opinion about Indians was not very high. in the general
Yeah.
populace, so to say. So my position was with Roger, and it turned out that there was another person who finished his PhD in particle physics, since you're asking about particle physics. So he was Turkish by name Cihan Sakliaglu, and so he was also going to Oxford, but he had done his PhD with Aichiro Nambu, who was very famous, who did get a Nobel Prize much later, and he was going to, and he was actually going with his American girlfriend. They were not married yet, so. And then there was but once I landed in Oxford, I remember when of course, we didn't go together. We went separately. And I was going through France. He was flying straight from the United States. And I mean, I remember when the train arrived in Oxford, right? I was all very excited, and 2 years of great intellectual adventure, and working with Roger Penrose, whom I had not met, just knew the name. It was a great name and such thing. So, but I land up there, and people were very nice with me. There were other people in Roger's group. First night, they let me stay with them, but it was not a very comfortable place to stay with. And I mean, they were like student types, and so things were not exactly neat in the apartment and so on. And I was looking for for a place to stay, and this Jihan Sakliaglu, the other person, he's Turkish, but he looks very white, and he was with the American girlfriend. She was white, of course, and so the college of the professor where he was going to work with offered him accommodation right away. The two of them got a flat, and they were settled, and I wasn't getting anything. And it was clearly, again, a racist thing. It took me quite some time to find accommodation. Finally, I did find. But it was not in Oxford proper. It was a little bit outside, called Headington Hill, which is actually a very pretty part in terms of nature. There was a little brook, so it was quite nice. And it turned out that my landlord was actually, his name was Hamilton, and he was one of the first pilots in the world. So he showed me his pilot license, and his pilot license had some number, like, I forget now, either 27 or 31. I don't remember exactly. It was a very, very early pilot. He got it kind of, and then he had spent some time in Australia. Then he came back again. He was British, and then he used to do this daredevil things, right? I mean, exhibits, like people would climb up, would fly up and go upside down and do all those things. So such things. But by the time I was there, he was quite old, and he drank one bottle of whiskey, scotch a day. It was quite a character, for his age and everything. But it was interesting. And so I had my own room, and it was perfectly fine. Then finally, I got my first check. I still didn't know how much I was earning, right? That check. The thing is, the taxes were much higher in England than in Chicago, particularly in the United States. Particularly because the United States, the taxes were for students, and there was some tax exemption, etc. So it turned out that my take-home salary as a postdoc in Oxford was actually less than my take-home salary in Chicago. So it was quite a shock, but still, I could pay the rent, and I could eat. I could cook at home, and I could eat and such things. So, and I even bought books, with a little bit of savings. And I used to go to Blackwell's and bought some books and such things. And in fact, one of the first books I bought was Hawking and Ellis, because it had just the Hawking's book on general relativity. It had come out the last year that I was in Chicago, but at that time it was quite cheap. At that time, I think, I don't know if I have it. It was something like £1 or something. It's quite cheap. And paper, of course, I could only buy paperback, and I still have it. But that was interesting because just a couple of years ago, they had a 50th anniversary of this book. Hawking and Ellis is called Large Scale Structure of Space-Time. Hawking wrote it while he was a kind of a postdoc. That'd be really amazing that they had so much knowledge as postdoc, compared to what I knew, for example. They wrote this masterpiece. It's a total monograph of general relativity, Hawking and G.F.R. Ellis was is a cosmologist. They're both young. They're both postdocs. They were students of Denis Sciama. And then just 3 years ago, they had a 50th anniversary new edition that the Cambridge University Press reissued up here. And for that edition, in fact, Cambridge University Press asked me to write the preface for that 50th. So in that 50th anniversary preface, actually, I do say that, this is one of my first purchases in Blackwell. So this book, Hawking and Ellis, I remember distinctly, and it was whatever the price it was. It is in my preface. If you can look at it, says that It is the best purchase I made because it was just £1 or £2 or something like that. Very, very small amount of money for this book.
Yeah, and such an incredible
Yeah, it was quite.
knowledge.
I mean, in those days, it was for me. It was, I was eager to learn everything from the book and so on. And I think the reason they asked me to write this preface on the 50th anniversary of the book was to see how this book then influenced over the years the community and thinking and so on and so forth.
Yeah.
And I sort of witnessed it throughout the 50 years, so I could tell them, what the perception was, what was most valuable, what was missing in the book, and everything. So that was quite interesting. Since we're talking about hockey, I mean, at Oxford, Roger had a very, very active group, but since Roger's postdocs were also invited to give talks, seminars, basically in London and in Cambridge. And so I did go to Cambridge to give talk. I think I went at least 2 times, maybe 3 times during my 2 years, which was quite nice. And they were always very, very gracious. Hawking was already suffering from his disorder, but in the beginning, you could speak and I could understand him in the
Okay.
1975. I could still understand him.
Mm-hmm.
Gary Gibbons, who was a very distinguished physicist, he was a former student of Stephen Hawking's. He just retired, in fact, a few years ago from Cambridge, and he was typically my host because Hawking had clearly great difficulties, and it was amazing that he functioned in spite of those difficulties at such a high intellectual level. It was really amazing to see him do that. So, and that was also the time when it was just aftermath of the Hawking effect discovery and what happens to black holes and radiation. But during this time, I was also thinking about something else, and so I asked Hawking, actually it was in the second visit, not the first visit. I asked Hawking about this idea. It had to do with what is called asymptotic structure of space-time. Basically, what are the boundary conditions that are appropriate for the geometry of space-time so that the space-time represents the gravitational field of an isolated body, like a black hole or a star or a sun or a moon or sun or a Earth, etc. So these are the things. And there's very surprising subtle issues that come up in this case. And Roger Penrose had worked on it a long time. And then there was one issue when it came to, he basically left it open, saying the issue of what happens in this particular limit. Technically, it is called I0. So let me just call it I0. What happens as you approach I0? So some way of going to infinity is a very hard problem and one doesn't know, etc. So I got interested in it because Rogers had said that is very interesting. And so I tried out my thoughts with Hawking. And he said something at that time which I didn't completely understand or completely believe. But then it turned out that what he said many, many years later, I understood what he must have meant. The way I interpreted it was not right, but what must have meant. And in fact, just 3 years ago, I started writing a series of papers at that time. Just about, and it turned after about 50 years, I wrote a continuation of that series of papers. So it was part 3 or part 4 or something of that series of paper as a tongue-in-cheek joke about over 50 years. And in that, in fact, there's the main result of that is what Hawking probably had in mind, but it was 50 years later. So in the acknowledgement, actually, I do thank Stephen Hawking for discussions in 1975. The paper is 23. So intellectually, it was very interesting atmosphere. Back to Oxford, what was kind of most interesting in those days was just the thrill of being with Roger Penrose. Roger had just discovered in 74, had made a major discovery. So I had to backtrack and talk a little bit about science. We'll more later. So, all of physics that we do normally happens in space-time. Space and time, space and is all around us, and time is flowing. So Einstein's great, insight and great discovery was that, in fact, we should not think of space and time separately, but we should fuse them into a 4-dimensional continuum. Normally, we think of space as being 3-dimensional, like this room that I'm sitting in, and all there is a length, breadth, and height, or X, Y, Z coordinates. And then there is time, and the time is flowing, and we think that two have nothing to do with each other. Einstein's great insight was that no, in fact, they naturally fuse to form a 4-dimensional continuum. And if you think in those terms, then some phenomena which had been discovered, or contradictions that had been arrived at with Newtonian theory and theory of electricity and magnetism due to Maxwell, can be resolved. And so space and time fuse into a four-dimensional continuum, Einstein's theory. So in Roger's group, people were thinking very much about this, how to do particular quantum physics in the space-time. But Roger had an idea that maybe space and time are not fundamental. Maybe they really are, even that is something, a derived thing. And what is fundamentally some other space, which he calls twistor space. It is still called twistor space, and that's called the twistor program, and so on and so forth. And and the idea is that that space is fundamental because, in the sense that description of fundamental physics becomes very simple in that space. And when you translate it to space-time, there will be some dictionary to translate it to what happens in space and time, and then it becomes more complicated. And Roger at that time thought that that was even true, not only with like photons or electromagnetic field. The quantum of electromagnetic field is a photon, and other simple fields like that, but it's also true with the gravity itself, gravitational field. That is to say, it is true with general relativity. So he thought that the correct way to look at general relativity would come from this, looking at it from starting with twistor space and then deriving general relativity coming from that. And we will have time to discuss a little bit more about this, because this whole idea of new variables and my approach to quantum gravity, loop quantum gravity, etc., has some, has its origin in this idea of twistor. It goes off in another direction. So I had a, so to say, the front seat in as these beautiful things were happening, unfolding every day, and so on and so forth. So frontline, very. And Roger was kind of, very, very active, and he was working closely with American physicist by name Ted Newman, who was also then later became a mentor and dear friend. And he was in Pittsburgh, and they would correspond. And Roger was doing it using twistor space, and Ted Newman was doing it with some other way of doing it. And they were corresponding to each other. And they were actually, we got Xerox copies of the letters, email, about the technical things, and we could read and see what is happening. So it was a very exciting era. And Roger had I was in the mathematical institute, so there was also the physics department and across the street, and astrophysics department a little bit further, and where Dennis Sharma was. Dennis Sharma was a mentor to Hawking, but also to Roger Penrose in early days. So it was a very exciting period. And in mathematical institute, there was always tea at 4 o'clock, and everybody got together at tea, and that is where one discussed what was happening. Until then, everybody was in their own offices or something. But people came to tea, and that was quite an interesting thing. And then Roger had a kind of a seminar in his office on every Friday. It started around 12:30, and then went on till till tea time. So it was so almost 4.5 hours of a seminar. But that seminar was not somebody was speaking, but basically everybody would sit together, bring their lunch with them, and then sandwiches, and then Roger would just say, who would like to say something? And then people would raise their hand and what it is. And then Roger would ask them to speak in some order. And people were basically telling about what was happening at that time. And Roger also had some, quite senior visitors who were on sabbatical visiting Oxford and such things. So it was a very, very lively atmosphere. And in particular, there were postdocs with me. I was a postdoc. Then there was another postdoc by name Paul Somers. It turned out that Paul actually was a student in Austin, Texas, when I was a student. He was a little bit ahead of me. So we had known each other, and he had I think a National Science Foundation fellowship, which was paying him in US dollars. So his salary was 4 times my salary. And also it was tax-free for him, and I had to pay taxes in Britain. And then there were 2 other British postdocs, George Sparling and Brian Bramson. And, it was a very active group and so on. And what was very nice was also that Roger was available even off times. And for example, I know once a week, his sons would come down from London. They used to live in London. And then we would go to, not every week, but we would often go to eat either with them or with just Roger in the pizza place, and then discuss on what is happening. And Roger would ask very, very probing questions, very hard questions. Because I told you I was working on this area that was, Roger had said that this is a hard problem, and was not this so-called I0 that I talked about. What happens to the gravitational field if you go away from the sources in some directions, and turned out technically to be very, very complicated. And so I started working with it. And it turned out that another postdoc was Richard Hansen, who was actually a former student of Bob Gorosh's. He was ahead of me, and he also was there. So it was, very nice actually. Some people from the old times, and some new people that I met, and intellectually very stimulating. By the way, the papers that then we wrote 2 years later, we wrote the first paper, which is 80 pages long paper in a journal, and that paper is cited even now. So that was one of the interesting things for me in Oxford. At that time, I didn't realize that all these things were kind of were foundational, that they will actually be built upon so much. So I worked in Oxford in two areas. One
Okay.
area was this, what I just mentioned. It had to do with what happens to gravitational field or space-time structure as you go away from the sources, from the stars or black holes, etc., in certain directions, in certain limits. In those limits, you are supposed to be able to tell what is the total mass of the system, what is the total energy of the system, what is the total momentum of the system, what is the total angular momentum of the system. And there were really deep difficulties in defining angular momentum, for example, and understanding if you go away from sources in one direction versus in another direction. Technically, if there are some students who know relativity, if you go along in so-called space-like direction, that was an open problem, as opposed to what happens if you go in null direction, that is to say the direction along which light travels. That Roger had actually worked out in great detail, but the going in space-like direction was Roger had not worked out. And trying to put together going in one direction and going in another direction, you should have a coherent, consistent picture of how
Hmm. Yes.
this total energy, momentum, etc. They agree in some ways. So that was this challenge, and that is the thing that I was working on. The work, it turned out, it took us quite some time to do it, but then it turned out to be a foundational paper, as I was mentioning. And then there was a second area, and that was really more along the lines of what I was doing in Chicago, and that had to do with this a little bit of like Hawking effect also. And Hawking was very interested in this in particular, which is really the idea as to what is it that you need to describe fields like electromagnetic field, like photons, electromagnetic waves, and so on. One knew how to do it in classical physics, but how do you do
Mm-hmm.
it in quantum physics and when you are curved space-time? So people knew how to do electromagnetic waves and such things, for example, or general fields. Classically, they knew how to do it in curved space-time. Quantum mechanically, they knew how to do it in flat space-time. But the
Hmm.
idea of how do you do this in how do you do quantum fields in curved space-time was a new area, and that is what Hawking had actually worked on, and that was his major discovery about what happens to black holes. Black holes radiate quantum mechanically. That was a major discovery that he had. So what I wanted to do was kind of in some ways again foundational as to what are the new conceptual and mathematical elements needed to go from describing quantum fields in flat space-time, like that is what is used in particle physics all the time, to curved space-time. What is that is needed? And then I discovered that what is needed is really a certain mathematical structure called the complex structure. And that is still something that is very important. It is being used. This way of doing quantum field theory in curved space-times is used even today. And particularly, it's sort of very, very recently, but I mean, last 5 years or so, there is a lot of surge of interest in quantum field theory and in quantum information. And that is to do with quantum computing and various ideas. And in quantum information, at foundational level, these things called complex structures, they become important. Now, this was in part an outgrowth of what I was doing in in Chicago when I was trying to do quantum gravity in this new way and so on and so forth. I had learned this new structure that is needed. But it was also hammered into me much more by an idea of Roger Penrose's. And that is, I mean, it's something that is known, but people don't always emphasize it so much. Namely, that there is a big difference between describing the classical world, that is to say, classical physics, and quantum physics. In classical physics, we can do everything with real numbers. I mean, you can introduce complex numbers as a mathematical tool, if you like, but nothing in nature is complex in classical physics. I mean, the electromagnetic field is real, gravitational field is real, and it's not complex. Whereas in quantum mechanics, complex numbers are at the heart, and that is the wave function is a complex valued thing, and that's really really
Yes.
important. There's complex valued. Without that, the quantum interference that happens, which is important for so many things, is not possible with
Yeah.
just real fields. You need these complex fields very much. I mean, and so the question So this was hammered into me by, repeatedly by Roger's idea that nature is complex. So therefore, in fact, Roger went to the extreme, and he was actually replacing real space-time with complex twistor space. Twistor space is a complex space. I didn't go that far, but I said, well, to do quantum fields, you need an additional structure in the real space-time, or on the space of fields in this real space-time, and that is called this complex structure technically. And so that was also kind of a foundational discovery. And at that time, I didn't realize it was going to be so important. But again, both these things, I not consciously thought of this until I was thinking of our interview as to what has happened in 50 years something. What was I doing in Oxford, and then it is only now that I realized that it's quite striking that two things that I was working on in Oxford, not just typically you work on it, and even if it is very interesting, there's a peak, and then after 5 years, then other things take over, etc. Whereas these foundational things these papers are still quoted today. I mean, two new papers were written go back to this because something is based on these papers, and so that I think is quite a interesting thing, and that could happen because of this very stimulating atmosphere in Oxford. So I mean, last time I told you how in Chicago I learned very different things from Bob Garosh and from Chandra.
Yeah, with Penrose, I think the style might be completely different because he is a very deep thinker, if I'm not wrong.
Right. So, I mean, Bob Garosh was, as I said, I mean, except for John von Neumann, Chandra said Bob Garosh is the brightest person that he has ever met. So Bob's was very characterized by speed, by how fast he understood and made things, and by clarity. And then at one stage, I was a little bit surprised by this because Chandra said that, well, in terms of talks, I thought that Bob Garosh's talks were the best one that I had heard of, so to say. Bob's talks are very, very good, but I think Andrei Trautmann, who was a senior relativist in Poland, he is a founder of the relativity school in some ways in Poland, the current relativity school in Poland up here. I mean, he's retired many years ago. He was already senior at the time when I was a postdoc. So he said, Andrei Trautmann, it is not as crystal clear, Andrei Trautmann's talk, as Bob Garosh's are, but in some ways you are left with the feeling that there are nuances to be understood, whereas in Bob's talk is left everything is so clear that in some sense you don't feel at the end that I could think about something, whereas with Andre's talk one could think about something in future and so on.
Yeah, you go out of the room with some questions in mind how this happens.
Exactly. So I think that and especially when Roger was working on this, how to describe gravitational field in using twistor space, he had a very, very mathematically very deep construction. It goes under the name of nonlinear graviton. And it was basically a certain kind of solutions to Einstein's equations, which are very simple in twistor space. And therefore, Roger thought that these would be the fundamental constituents of space-time. But they're complex solutions. They're not real solutions. And again, he thought the complex thing is really fundamental. I mean, just to sort of say that we're going to come back to this, but this idea has not yet worked. All these 50 years have passed, but this idea has not yet worked. I mean, Roger has not been able, or twistor theory people have not been able to come to the real general relativity from this complex building blocks. These complex building blocks are very simple properties, and in some ways, one has the feeling that you must be able to combine them to get the real space, but one has not been.
Because of the mathematical beauty that they
Exactly. So I think it's not quite. I realize that it's not really. I mean, Dirac used to say that if there is a beautiful mathematical ideas, it will eventually find its home in physics. It will be fundamental in physics as well. I feel that there are several things that I've seen in life which are mathematically very beautiful, but I think they're not physics in terms of physics.
They are
Not that. For example, there's an approach to quantum gravity called non-commutative geometry. It's a very beautiful mathematical approach, a lot of work that is being done, but I don't think it is captured in the real physics in it. So there is it could be that, 200 years from now, people will realize, of course, one can never know that. Usually these things don't happen, right? If some things are not picked up within 50 years, then they probably decay in some ways, or 100 years, then they probably decay. Anyway, so the point was that, I was very motivated by this Roger's idea about complex structures being fundamental. And so I introduced this way of doing quantum field theory and doing And the second thing was quantum field theory using the so-called complex structures as being fundamental thing, and that is now being used in quantum information, as I just mentioned. And the second thing was about this asymptotic structure of space-time, which also turned out to be very, very important. I mean, the main thing is that what I learned was seeing Roger in action, so to say, because I think that in terms of mathematical and conceptual subtlety and beauty and intricacy, this nonlinear graviton is probably the, it turned out not to be the most useful, but still the highest aesthetic contribution of Roger Penrose. I mean, as they say often about Gauss, right? Gauss is considered to be one of the three greatest mathematicians who ever lived. The first was Archimedes, second was Gauss, and third is Newton, they say. So, but Gauss spent more of his lifetime doing astronomy, actually doing observations and such things, than mathematics. But he is much more known for his mathematics than for astronomy. So Roger similarly has spent a lot of time doing twistor theory, but he's much more known for his earlier work on black holes and ideas, singularities and Penrose diagrams and such things. But still, he was at this height of his power and trying to have this nonlinear graviton construction, and it was unfolding in front of our eyes. And as I said, there was this hectic interaction between him and Ted Newman, and these letters and so on. So what I learned from those interactions is something that I had not learned in Chicago so much, which is in some sense I saw Roger kind of groping in the dark to find some shapes which you don't know where they are or something. He did not have that clarity that Bob Gorosh had, right? Completely. But he was groping in the dark to find some shapes, and before they actually come to light, right? I mean, he could sense that there is something here, right? And then after a while, they emerge, and they emerge in pristine beauty and everything. And this thing, I think, is something that is very, very deep, and that is what I feel is, in my view, makes
sometimes mind working so mysteriously, like Ramanujan's mind is one mystery, right, in itself. Like, how did he arrive at those results, without formally proving them? And so, it's kind of mystery in a sense that, how mind makes those leaps and jumps.
That's right. There's some kind of very higher level, very, very high level creativity that is involved here, which is something that I got to witness. And I think that was my greatest blessing. I mean, there are many, many blessings I had in Oxford. For example, there was also Michael Atiyah, field medalist and very, very, very influential mathematician. With an Indian mathematician, TIFR at that time, by name Patodi, he actually had this very important theorems, Atiyah-Patodi theorems and so on and so forth. So, but he has done a lot of other things as well. And so again, just having Atiyah in the room, in the building, and seeing him at tea saying about something, and even if you didn't understand the technical details, you saw the spark. There was an intellectual spark and light in the room, which was very, 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 very.
So during that phase of your life as a postdoc student, were you like more matured in terms of slow going and deeply thinking about things? You had a lot of new ideas coming to your mind now and then, and going and discussing with people. What was general?
There's a mixture of the two, both those things. I think by nature, maybe because I grew up in India, where there's not that many people to talk to when I was growing up and such things.
Yes.
That somehow I seem to have a tendency. I again didn't realize at that time, but in which the deeper things that I do, I sort of have to withdraw and not being always interaction somehow. In other words, what I mean by this is following that there are discussions in these things. These are the issues which are not at the hot button issues at the time. So new things are not coming out every other day. See, there are people who thrive by being really on the frontier, in the sense of new ideas are coming out and they can keep track. But often, not always, but often these new ideas, they change, and it requires a very special skill to keep abreast of those new ideas and make the appropriate contribution at that time. But very often, what these people do they are very, very influential in pushing the frontier, but they push a frontier a little bit, right? They don't cause a revolution. They don't change conceptually something dramatically, because it's always going to be incrementally. Go this way or this way. Not let's just think outside the box. Maybe neither this way nor that way. Some other way. That it is not time for that, right? Because the new ideas, new results are coming in, and you have to react to that. And maybe because of looking at Chandra, Chandra was the master of this, of not being worried about the latest craze, latest fashion, latest something, but taking an area and understanding it is completely deeply and, really polishing it well and then going to something else.
And I think Professor Chandra used to publish a book at near the end of it, which would be a summary of the field and then move on to something
That's
else.
exactly right. So basically, a summary of the work that he had done in those last 10 years, or some in case of general relativity, it's close to 30 to 20 plus years in general relativity. Yeah, so you write a very authoritative monograph on that, and then that would be the.
Before we move to our next section, I would like to ask advice for postdoctoral students. Many early career physicists move between temporary positions while pursuing permanent roles. Permanent role is something that gives them stability in terms of focusing on big ideas or research ideas which they want to pursue irrespective of worrying about the projects and grants, especially this generally creates a stress among the postdoctoral students at this age, because the responsibility is also growing with age. They have children now, they have other responsibilities. So looking back on your own journey, what advice would you offer to early career physicists, especially at this stage, navigating the challenges?
So I think it's similar to something that I said maybe a couple of sessions before. It is difficult. There's no question about it. I mean, I remember feeling, not at the end of my second postdoc, which we'll talk about in a minute, feeling very much that I'm in a tunnel and I don't know the end. Is there light at the end, or am I just going to be just? So there was definitely that feeling. So I think I'm just saying this because I did come out, and so it is possible to come out of the tunnel. So people should not be discouraged if they feel that way. But in some ways, I think you have to have inner conviction that what you're doing is something that really, there's the inner fire that you believe in it in some way. And it is important in the sense that it's not is going to necessarily change the world or something, but it has a potential of making a deep impact. And that, I think you have to have that conviction and to keep working on that thing, right? I mean, it is difficult. And you correctly pinpointed the tensions. Basically, because there is no security. You go from 2 years, 2 years, 2 years, or
Yeah.
maybe at most 3 years somewhere and such thing. And then what happens after that? We don't know that, right? What is going to happen after that? And in fact, the standard attrition rate is really a factor of 3. That is to say, 1/3 of the students would get postdocs and 1/3 of the postdocs would get a faculty position. So it's only 10% of the students would get a faculty position. So there's competition, unfortunately. I think it's good to have a healthy competition, but sometimes it becomes sneaky and this doesn't become very nice. But I think one should try to keep out of that and try to focus more on what is the best work you can do at this stage. Because there is other side of the coin, which is that with security, your responsibilities grow enormously. Because when you're a postdoc, you're free, right? I mean, you did not write the grant, somebody else wrote the grant. And so you're not writing proposals at that time. You don't have students to supervise. You don't have letters of recommendations to write. The time of my life I spent on writing recommendations. I don't know. I mean, if I put all together, it may be counted in years, because I had more than 70 postdocs, more than 30 students, so there are 110 of them already, and they go through stages. I mean, the student becomes postdoc becomes a faculty position, then there is a promotion, then there is tenure, then there is something, then there are prizes, then there is, and people, I mean, and for natural reasons, people ask people in their 40s, 50s to write also for their senior people, those who have come to the senior level, and those things take time, right? So students
Yes.
and postdocs don't have that. They don't have committee
Yeah.
work. I mean, when you're a department, you have to have committees. You have this committee, admission committee, syllabus committee, whatever committee, and it takes time to go through all those things. So I think that the best thing is to realize that even though one is feeling that, well, one has no security and so on, there's the other side of the coin, which is that you also don't have kind of responsibilities, which are huge sinks of time, and therefore you can really take this time to dive into
Your idea
your
and
ideas, and also broadening your intellectual breadth. I mean, don't be too narrow. You should be reasonable. For example, I profited a great deal, so for students and postdocs, by reading these authoritative biographies, not junky biographies, but like the on Niels Bohr, on how Niels Bohr created the Bohr Institute.
Hmm.
Yeah, I was mentioning to you that I was interviewed by these philosophers of science, and many interviews. I mean, more on scientific contributions. The first session took place in the Bohr Institute, Niels Bohr Institute in Copenhagen. So, there I seen firsthand the archives and how those things are done and what happened to the history. Got to see Bohr's own office. That one office, I left it as it is, and they're not changed at all. So these people built something. I mean, at one stage, everybody was in Niels Bohr Institute, right? I mean, Heisenberg, Pauli, you just name it, right? I mean, everybody was in Chandra at times, as better. Everybody that you can think of passed to Bohr Institute at that time, in that age group. And so it was very good for me to read about this thing. It was very good for me to read about Heisenberg's biography, for example, which is called Uncertainty, and it is by Cassidy. I mean, I read several of them, but this one is, I think, is very, very good because you see how many. It is a complicated life for Heisenberg, right? I mean, on the one hand, he did these great discoveries. On the other hand, he did not leave Nazi Germany, so he was deeply criticized for that. And I often thought about myself and my colleagues as being extremely lucky that we did not have to make such hard decisions in our life. That
Yeah, absolutely.
and so it's good. So I think it enriches you. When I was doing quantum gravity, I purposely went out and read about history of quantum mechanics, not because I wanted to. That's not the way to learn quantum mechanics. I strongly urge people who are learning quantum mechanics not to go through the historical route. I think that's wrong. Just learn it in the best, clearest possible way that we have today, because giants made all kinds of mistakes and such thing to crooked path to arrive where we are here. To be able to use quantum mechanics, learn it from the point of view that we have today, and what is the clearest way to learn it and how to solve it. That's the most efficient way. But once you are mature enough, it's also good to good back to see how was quantum mechanics discovered, how was relativity discovered. Much later. Don't do it when you're postdocs or students, but much later, because you then learn you know, how to embark on much bigger projects. As a postdoc, you don't have enough knowledge to embark on much bigger. But so my statement is that don't be discouraged. Yes, I mean, even people who have been very, very successful at the end, they also have felt that they were completely trapped and they were very concerned about future. Second is that focus on your work, and but also broaden out, learn as much as you can in terms of techniques and tools and such things. And finally, make contacts, right? Make contacts with scientific contacts with both your generation people, because they will grow with you, and also with the more senior people that you can, go and ask questions, and good senior people will always listen. Okay.
After Oxford, what were your next career steps? How did you transition from postdoc to your?
There are two things after that. One was actually then at the end of my 2 years in Oxford, Roger was very kind. He thought that I could stay for a third year. But I felt that there were not that many jobs in England. And furthermore, with an Indian passport, I may not have such a um, great career path there. And anyway, just being geographically separated was, I could not go and give seminars in the US universities, for example. Whereas if you are in the United States, they might invite you to give seminars. So I thought I should go back to the US. There are not that many postdoc positions open, but it turned out that without even my asking, I got a letter from Chicago, from Bob, saying that if I wanted to go back as a postdoc, I'm very welcome to come back to Chicago as a postdoc. And then I also got a couple of other offers, not too many, I think, or three in all. But Bob was very generous. He sort of said that, well, you can think about it, with other things. So I thought about it, and I've kind of finally felt that even though in some ways it's not a good idea to go back to the same place that you did your PhD, it was still, the group had changed a little bit. They had new faculty members, and there are other postdocs and such things. I thought that maybe it would be good to go back. And so I decided to go back to Chicago as a postdoc. But before going to Chicago, it turned out that in the end of my postdoc in Oxford, so it was the summer of 1976, there was a school in Cincinnati, summer school, or school, a conference actually, because only 10 days long. It was not a school, not a month long. It was about on topics that interested me, and in particularly Bob Garosh was going to be lecturing on asymptotic structure of space-time that I had gotten interested in at that time, since I left Chicago very much. And so I thought that I should, I could try to attend. So I applied for some financial aid. They gave me some money for travel and such thing. So I decided to go there. And it turned out, I don't remember the details of how it happened, but it turned out that at that time, the people in Syracuse in New York, that was another rather major gravity center that was founded by Peter Bergman, as mentioned to you, was an assistant of Einstein's earlier. They kind of invited me, or they thought that it would be good if I passed through Chicago, through Syracuse, and if I was coming. And so at that time, I made the trip from Oxford to United States, and I went through Chicago, through Syracuse, and then one of the faculty members in Syracuse, Kamesh Wali, who wrote the biography of Chandra, the authoritative biography of Kamesh. So he actually was very, very nice. He was another of my mentors. And also there was a relativist by named Josh Goldberg, physicist. He was he was also very, very nice, and he was at that time the chair of the department in Syracuse. And so I went to. They both hosted me, and we gave some talks, and then I think Kamesh was driving to Chicago, so I got a ride with him. And then Bob Garosh was driving from Chicago to Cincinnati, so I got a ride with him. And these rides are good because there's long hours in car that you can talk, you can discuss, you can think, and there's a little bit more informal atmosphere, so you might ask questions that you might otherwise feel a little bit awkward to ask and such thing. And then but I learned a lot in Bob's lectures. And also there were other lectures by Leonard Parker, which was on quantum field theory and curved space-time. I think Parker's ideas were probably, if I followed them up more closely, they would have led to more practical applications rather than foundational things. At that time, I was interested more in foundational things. So this was quite a good thing because I made some contact with Syracuse, because that was my beginning of my relationship with Syracuse, and I landed up in Syracuse and faculty a few years later. And then when I was back in Syracuse, in Chicago, right, I continued on this work on asymptotics. The work on quantum field theory in curved space-time was put on the back burner in some ways. It came back in soon afterwards. But I worked on asymptotics because I was combining the ideas I had developed in Oxford with the ideas that Bob Garosh had developed. And I think together there was a very non-trivial jump that happened in the field of asymptotics by this combining these two ideas. And I wrote a whole bunch of papers, quite a lot of these papers on that. And then there was something that was kind of, I have to say these things because I think it's good to be saying things that you're embarrassed about also. So I'm very embarrassed about the following thing. I had this kind of I was interested in many things. So I had a disrespect towards rules, regulations, authorities, and such things. That was, I mean, to some extent, it is okay to have that disrespect, but maybe sometimes you cross boundaries of that. And so what happened is that I had passed my final oral exam in Chicago, but I had to submit my thesis paper to a journal, and I submitted to a journal, and then the referee report came back when I was in Oxford. I submitted it because it was the end of my Chicago period after the final exam that I submitted it, and then I went to Oxford. And the referee report had several points that I had to change, I had to make things. I was not so accustomed to referee reports, and also the second point is the thing that I'm embarrassed about, mainly that I had this idea that, well, things that I'm doing now, this two quantum field theory in curved space-times, and these complex structures, and this asymptotic structure of space-time with I0, they were so exciting that to go back to this and fix those things and rewrite the paper and so on, I kept postponing. And that was bad because I did not get my final PhD degree. And because I had never got a master's degree, the only degree I had was a BSc from University of Chicago, of Bombay, right, at that time. Although I was hired as a postdoctoral assistant by Mathematical Institute, and then I was back in Chicago as a postdoc, and I was being paid by NSF as a postdoc. I did not have a PhD. I did not have the piece of paper which says that I have a PhD, right? I was publishing, and that, I think, that kind of carelessness, I really very strongly advising people not to have. I mean, it's all right to be a little rebellious, but there's a limit, and I think they should know the limit because you can pay a heavy price. I mean, I just barely escaped the heavy price because it turned out that there was this associate head of the department. I might have mentioned it the very first time. So his name was Saul Krasner. I told you that when you enter his office, there was a big picture frame, and the last thing was your
Yeah.
with all Nobel laureates. The last thing was supposed to be you, and so. But this Saul Krasner was very interested in uh, keeping track of people and something. And then what happened is that when I was in my first year in Chicago, so my third year of postdoc, there was every year there is a Gravity Foundation competition, and for some reason that is what is listed in the Wikipedia. That is not one of the major prizes or something. Anyway, so I use write an essay, which is really a paper, but they call it essays on some idea, and the idea was the originality of the idea or something. That is what is more important than anything. But it turned out that this prize got kind of its prestige got suddenly elevated enormously because both Penrose and Hawking submitted essays, and they both each of them got the prize. And Chandra even told me, "Why is Roger sending this thing?" And so anyway, uh, but anyway, so I was just a mere postdoc, so I said this, and I got a first prize, right? So this first prize was again, Chicago University has, I mean, these big universities, the famous ones, they have a whole machine which keeps track of who got prizes from university. So it was listed somewhere, and Saul Krasner saw that. It turned out that it was it came out around the same time as Pfefferman was a mathematician in Chicago, got the Fields Medal, and so there was listing, and because of my name, probably my prize was above Pfefferman's Fields Medal, which was totally ridiculous. Right? And so, anyways, so Krasner then somehow slightly got concerned that it would look bad if I don't have a PhD from Chicago and I was getting these prizes, so I might be very successful as a physicist. And so he came. I am so grateful to him. He came and said, "But you have several papers, so why don't we take one of your papers and call that your thesis?" So it turned out that I had one paper which was single author that was necessary, and it was actually was an invited article for Einstein's centenary volume, Einstein's 100th birthday volume, which was published, and that had been accepted. So that paper, which was about asymptotic structure of space-time, which are completely new ideas that ever happened. And by the way, in that paper, I redid the work that I had done with Hansen and really put it in the definitive form. And that definitive form is now used everywhere. So in some ways, my official thesis turns out to be quite influential, but that is just an accident that it became my official thesis. So that was submitted. There was another administrative thing that I was stupid. I did not do in time. So as a result, I got the PhD in 1978, even though my final exam was in 74. So it looked that either I took too long to become to get my PhD, or I took too short to become a professor, full professor, starting from my. So then after Chicago, the question was what exactly to do, and in part because of personal issues, and in part because I got a faculty position in France, and so I decided to go to France for 2 years, and it was a visiting faculty position. But then I realized, actually, while thinking about it much later, that it was actually a blessing in disguise, because that was a place where there was nobody to talk to in my area. I mean, no senior people. There were no postdocs, there were no students. I had visiting, so I had very light duties, but I had a professorial salary, if you like, but it was not permanent. It was they had these jobs for people who are foreign. I mean, who are not French. I mean, and so I had this professorship there, and so. But then in those years, I worked quite a lot, and I wrote 15 papers in those 2 years. I just was looking at it this morning as to what did I do when I was there, and again I started a new thing from this, combining the ideas from quantum gravity that I had picked up also with the ideas of a few ideas which are around when I was in Oxford. So quantum gravity ideas as a student and a few ideas from Oxford, together with what I had learned about this asymptotic structure of space-time. Basically, as I was telling you, that Roger had done something, Bob Garrosh had done something, but then I realized that there's another level at which we can do, which I felt was more, it had more potential. In that sense, it was deeper because it has more potential. And so basically, I was able to do quantum gravity of fields which are at infinity. So the statement is that It is called asymptotic condensation because you are far away from sources there, and one could do it exactly, which was kind of surprising, and that turned out to be uh, uh, the foundational thing for what is now being done. So this is something that I did in between 78 and 80. That is when I was in France as associate, as a, they call it professor associate, which means actually visiting professor. And that was and then I was in there was an Oxford symposium, second symposium on quantum gravity, that I was invited to. Roger invited me, so I went there from France, and I presented this paper, this new work, which is asymptotic quantization, that you can actually do exact quantization of it. Combined ideas of Roger's nonlinear graviton, but then it completed the program in the sense that I was not talking about complex spacetimes, I was talking about real spacetimes and so
Yes.
on. And I was talking about observables that people actually use in quantum theory and so on and so forth. It is it's a niche, it's a corner of quantum gravity that one understands well. But then this work was, I mean, Roger thought it was very, very important. Roger invited me for another workshop after that called for the field workshop, and he thought this was very important, and this was a way to understand all kinds of things that, you know, Roger and Bondi and Mesner and Sachs and British group had discovered about gravitational waves in the mid 60s, and he thought this was really very, very, you know, apt contribution to that, and so on and so forth. So a few people thought it was very important, very deep, and so on, and that helped me, of course, because these people wrote letters of recommendation for me and such things. But it did not catch on. Interestingly, it caught on around about 10 years ago, 2014. So almost 30 plus years after I had written this work. And now it's everywhere, right? People are using it all the time. It is this idea about asymptotic quantization. They're using this, they call celestial holography, they call scattering amplitudes. But the foundations of that were all done in this place where I had nobody around me to talk to every day. I mean, I did write letters, and letters communications were very, very good. I had some very useful correspondence with Bob Gorosh, but it was not everyday type of thing. And at that time, since I was in Europe, I could also visit Max Planck Institute, where Jürgen Ehlers, I mentioned to you, Jürgen Ehlers was a professor in Texas. He had been called back to Germany as a director, as one of the directors of the Max Planck Institute in Munich. And so I visited Munich to Jürgen's group up here. And I still remember that when I had finished this asymptotic conversation, I was so bubbling with ideas, and I felt like, oh boy, I mean, everything fits together, how beautiful everything is. When everything fits together, it's really the real thing, you know. I mean, it is there.
Yeah.
This is again one of the wonders of general relativity and Einstein's ideas, how things, intricate things, complicated things, subtle things fit together, and the final picture is more beautiful than you had imagined, right? I mean, that is the way things, that is what gives us more.
So this final picture, get putting all things together, and then finally you see the whole picture, which is much more elegant. At what point you realize that you were on something really important, and this is something that you are realizing for the first time in the history?
Yeah, so it is not in the beginning, of course. I mean, in the beginning, you think this is important, but you don't realize how important it is in some ways. It is really towards the end of finishing this picture. Then, once you sort of see that everything does fit together, then you feel, really has a potential. And this is kind of, so it is really towards the end of the process that one feels.
And when did this happen? When was this moment?
This was also in when I was, I was in France with no other colleagues around me.
Okay.
But then I felt that I had to communicate. It is just too beautiful to just keep it to yourself. You communicate. I mean, I wrote papers, but more than that. And then I remember going to Max Planck Institute and giving a seminar on this. George Ellis, who wrote the book with Hawking, was visiting there, and Jürgen Ellis was there, and my friend Bernd Schmidt. They were much more senior than me, but we had become friends. They were there. Jürgen was still my mentor. So I remember giving this talk, and it took an hour and a half, just blackboard talk, and there was so much material in there, and so many things were fitting together. I was saying that George Ellis told me, but that there are too many ideas here. And I said, yes. I said, I could not give this talk anywhere except in Jürgen's group, because Jürgen Ellis is one person who understands all those things. Then the end of my stay in France, there was a summer school in Alps, a place called Lejus, which is a very beautiful place, very high up in the mountains near the peak, which is called Chamonix. That summer school was on actually another area which had to do with gravitational waves. I mean, I had worked on gravitational waves, but not in terms of detection of gravitational waves. It was more like foundational theory of gravitational waves, right? So I applied to that. I was not invited to speak or anything, but I was applied to that. And then they did invite me to organize and chair a panel on a specific topic, which is called equations of motion or two-body problem in general relativity. If you have two black holes or two stars going around each other, can you solve? The thing is that in general relativity, we cannot solve it exactly because the two bodies are radiating. In Newtonian theory, we do, and that's how we know what the orbit of Earth is around Sun. Sun is the one body, and Earth is the other body, and we can. But in general relativity, even Earth actually going around is going to be radiating gravitational waves. And it is a very complicated problem. The effect is tiny, so we can ignore it. Fortunately, we don't have to worry about it. But if two black holes are going around, the effect is huge, and you cannot ignore it. And therefore, you have to, you have to take into account general relativity completely. And so, this topic had just started. A few years ago. So this was 78, and this topic was drawing attention. And so they asked me to organize a roundtable discussion on this topic. And at that time, there was so much controversy about everything. And I'm mentioning this because just 2 weeks ago, right, I was invited to a conference which will take place in September, in Germany, about these equations of motion. And in part, I was invited because I was what I had done was one of the first sessions that I had organized on these equations of motion. And so, how far do I come from now? Since then, I have contributed to this area also, not enormously, but a little bit. And so I can speak about what happened in 1978, what we knew about that, and what we know now, and also can point out direction to future. So things are intertwined. I mean, things seem to fade away, but then they reappear, and so the things are not linear like that. The last year in Chicago, I took one quarter. Chicago has a quarter system. There are 4 quarters instead of 3 semesters. So so I took the second quarter, which is roughly speaking until October, November, December. That quarter, I took off and I came to India because at that time I had this idea that if enough of us students at that time went back to India, we might be able to make some impact somewhere. And in Chicago, I had even started uh, an association with people that I knew of my age, various places that we were. I mean, actually, even students who were students with me in Mumbai at that time, and who had some in mathematics, some in chemistry, some in physics, and so on. And I said, well, look, if any of us went back to some university, there will be no research and it will dry up very soon. But maybe we can go as a group. Maybe somebody can hire us as a group. And then there will be a good chance that we can keep alive,
Collaboration.
stimulate each other, so to say. And so I think we were about the order of a dozen people that we signed up. I created this association, and then I wrote to various vice chancellors in Chicago, in India, saying that we had this group and we would like to, our concern is that individually people get dry up, but if together we might be able to and enliven the place and such thing. I mean, I had to write it in a very somewhat diplomatic way because not to seem it sound that their universities did not have much research, which is a fact.
Yeah.
And unfortunately, only 2 of the vice chancellors replied, and I was going to, take it on that. But so that is why I visited India. So this must have been 1973, 4, and I visited Raman Institute in Bangalore, and also the Indian Institute of Science, their Center for Theoretical CTS. It was called Center for Theoretical Studies. That Sudarshan, who I had known in Texas, was official director, although he was only visiting. But his former student Mukunda was more or less in charge, and I came to know Mukunda very well. They were very nice to us, to me. I mean, nice to me and my friends who come to visit and such things. So I spent some time in these 2 institutes to get a feel for the research. And I thought that, maybe one can start something in one of these 2 institutes up here. There was somebody in Raman Institute who had just come back by the name Rajendra Bhandari, who had just come back from Berkeley. And he was interested in foundation of quantum mechanics. And I thought that would be a good thing. Raman's son, V. Radhakrishnan, had just come back from Australia. He was a radio astronomer, and he was the new director of the institute. He was trying to revamp the institute. And so he was interested in what I had to say about this institute and the idea. I was very, very kind and very, very open to suggestions and so on. So, I mean, more or less, all that left a very positive impression on me. And then after France, after this 2 years in 78 to 80, in 80, I went back to India and I revisited the Raman Institute at Radhakrishnan's invitation. And I just spent a month or so there. That by then, there was already a little bit of gravity group there by a person by name C.V. Vishweshwara. He was a relativist. He had got his degree from Maryland, and he actually did some pioneering work in black holes. And so there was a small group, and so I interacted with them again, a lot of seminars and such thing, and so there was this connection with India very much. Both at the end of my PhD, so it was 73, 74, and then in 1980.
80s.
So that was kind of my connection with India. So the question was about faculty positions, and at that time I had applied to faculty positions, I should say, when I was a postdoc in Chicago. There was only one open in those 2 years, because I told you every 2 years there is one position open, and that was in Chapel Hill in North Carolina. They had a gravity group there also, and I didn't get it. Somebody else got it. I guess that person already had finished 4 years of postdoc. I just only finished 2 years of postdoc when I had applied, and again there was only one position. So that's one of the reasons why I felt that I could go to France, and at least that will be a faculty position, so I will be put in a certain echelon that I will take over. And so, but I mean, then 2 years later, we were back in the same boat. But I was extremely, extremely fortunate that at that time, National Science Foundation had started a program in gravitational physics. They had realized that, like Chandra had realized and so on, that there were a lot of young people who were quite good, but there were no faculty positions. So they offered universities possibility that they would support the faculty member full salary, 100% salary for 3 years, one of these people, and then the university could absorb them or something. University would have a chance to observe them, and then therefore they could absorb them. So that's how I wrote a proposal to NSF. So Syracuse University, with whom I had contacts, that's why I mentioned before how I set up the contacts to Syracuse University on my way to Cincinnati work play. And since then, I kept in touch with them. And I guess they had heard from Roger, they had heard from various other people, from Bob Garosh, who was also had been in Syracuse. There was some contact up here. So they opened up a position under this auspices of National Science Foundation, and I wrote this proposal. And then in 1980, that proposal was actually successful, and so that is when I went to Syracuse as a faculty member. I mean, the people were so nice, and I was every so much trust or something. I remember when I went to Syracuse, the question was about again finding accommodation and such thing, and Professor Wali, Kamesh Wali, and his wife Kashi, they were so nice to us. I mean, he actually suggested that maybe they could find a small house for us and buy. The problem was that, you had to complete this process in summer, because new people come in and start in the fall, right? So if you arrive in September, which is called the fall, the beginning of the semester, then there are no houses to be bought. Almost the market is gone. The market is open basically a few months before that, and so that is a high season for houses in the United States. So they said that, I mean, it was too much to fly from France to the US just to look for a house, and so they just bought a house for us. I mean, we paid the money, but they just selected the house for us, and then I just paid them, the mortgage, the first payment, the down payment, as I call it, or something, and then they started mortgage. So once I came to Syracuse. So in 1980 September is when I started in Syracuse, and we can take up about this later.